In computing student grades using nersapp, you have to make use of your CAE scheme. The CAE scheme might work with some values. Those values are called literal scores or literal formulas. For instance, you can see here we have the test 1 having a value of 30, exam having 70. Then on total score we have the test 1 plus exam. This is an example of a formula that is derived by adding test 1 here plus exam. So what you are saying is that nersapp, whenever there is a test 1, an exam score, colon for total score, simply add test 1 plus exams. So this formula is very helpful, so you don't have to do all the work of calculations on your own. And this formula could be advanced. It could be written in so many ways that you deem it fit. So in this tutorial, we're going to show you how to work with nersapp arithmetic operators and nersapp logical operators. But before we go into that, there are some other forms of value which we talked about, which are the previous terms average grades and previous term grade. So these are not just literal, but they have their own additional meaning. What I'm saying here is that when you are trying to use them, there is no way you can compute data on this cell block again. So that's why this is not a literal. This stands on its own. Same thing if you're trying to use a previous term grade, it stands on its own. So there is no room for you to add a literal test score or a formula. But if you need to add a formula or a test score, you have to switch to literal. That gives you room to make those changes. So let's switch over to see how we could work with nersapp arithmetic operators. In nersapp, we have over 6 arithmetic operators that you can use in your formulas when you're trying to create a formula to compute certain grades. You have the plus sign on your keyboard, which is addition. An example is simply 2 plus 2, or 2 plus 3. We have 5. You have the asterisk sign, it's used for multiplication. 2 times 3 giving you 6. You have the minus sign in your keyboard, it's called a hyphen. It's for subtraction, that's 2 minus 3 equals -1. You have the forward slash, which is used for division. That's 4 divided by 2, giving you 2. Then we have the exponential sign, that's 2 asterisk sign. That is, if it's a 2 raised to the power 2 or 2 raised to the power 10. So that's what we mean by exponentiation. So 2 asterisk 2 equals 4. That's 2 raised to the power 2 equals 4. Then we have the bracket, very important sign. The bracket is used to derive order of operation. For instance, we put here 3 minus 2 in bracket, all right, before we multiply by 4. So what will happen is that nersapp would first compute 3 minus 2, giving us 1, and 1 will be multiplied by 4, giving us 4. So in nersapp, this is the order of operation. Just like in most school back then, we call it board mass. So same thing is applicable here too. Bracket takes place first, then exponentiation, then multiplication, then division, then addition, and then subtraction. So these are the nersapp arithmetic operators. And let's look at the nersapp logical operators. In nersapp, there are a few logic you can apply to your work in order for you to do computation effectively or advanced computation effectively. And these are for advanced educators that want to do much more. We'll give an example to depict this. So for logic has to do with conditions, things that evaluate to true or false. There are some logical signs here which we consider for basically in nersapp. One is the greater than sign. So this is the right angle brace. We use it for greater than sign. Example 3 is greater than 2. Yes. So this value is called a conditional value. All right, which is true, which we all know is true. Then the left angular sign or angular brace, which is less than. So example 3 less than 2 is false. We have the greater than or equals to, which is greater than or equals to. In nersapp, whenever you hear or, That's if you have two options. Take this or this. That means you must pick one. That means one of them must actually come to pass. So if you have, for instance, 3 is greater than or equals to 3, it's true. How is it so? Yes, 3 greater than 3 is false, but we know that 3 is equals to 3. So that makes it true. So one of them have to come to pass. Same thing here. We have less than or equal to. So example 3 is less than or equals to 3 is true. How? First, 3 is less than 3 is false. We know that. But we also know that 3 is equal to 3. So that makes it true. Yes, and finally, in nersapp, we also added a new feature. It's called the ternary operator. This is very useful, especially when you're dealing with PTG and PTAG. So example here, this is the structure of how the formula looked like. You would have your condition. This condition is any arithmetic calculation or operation in nersapp that would evaluate to true or false. For instance, if you look at in this example that we gave here, this is the calculation. Any arithmetic calculation that you do or logical calculation that you do, but it should evaluate, that means it should result to either true or false. Now, when this condition here is true, whatever you use here, as whatever value you use here would be considered as what you want to use as your final result. If this condition here is false, whatever value you use here would be the final result. Let me repeat that again. In a ternary operator, this is the formula. If you want to use that to evaluate two sets of values, assuming you have two options, you want to pick one. But you want to pick one based on a condition that must be met. For instance, if this condition here is true, whatever should be picked that should be true should be placed here. If this condition here is false, whatever should be picked that should be false should be placed here. And I said that this condition can be gotten by some basic arithmetic operation like 2 plus 3, 5. 5 in nersapp means true. Why? Because 5 is more like an actual value. But if it was 0, 0 means false. Or this condition can be gotten by doing what they call a logical operation. Like for instance, 3 is greater than 2 is true. Alright? Sometimes this condition here can be both arithmetic plus a logical operation. That's by combining them both. But the end result is that this, whatever value this takes two types of values, true or false. If it's true, then whatever you use here will be considered as your result. If this is false, then whatever you use here will be considered as a result. Take note, this is the structure, meaning that when you're writing or using this formula or this structure, you have to ensure that you put this question mark here and this colon here. So let's take a look at two examples here. We have 3 is greater than 2, question mark 3, colon 2. The final result is 3. How do we know? By mere looking at this, 3 is greater than 2, which result to true. So because it is true, the computer will make use of this as our final result. In this case, that's why we have 3 here. Another example, this one is a little bit complex. You can see here we place 4 plus 5 in a bracket and we say it's less than 3 times 2 in a bracket. So whatever this whole computation or formula or calculation would evaluate to, if it's true, 1 will be picked. If it's false, 0 will be picked. And the end of it is 0. How do we know that? First, you have to do the math in your head, or you can do it on paper. 4 plus 5, we know is 9. So we can just come here and place 9. It's less than 3 times 2, we know is 6. So put it there. So we do this, Okay, so you can see here that 3 or 9 is less than 6, which is false. 9 is not less than 6. So because it is false, 0 will be picked as our final result. So that is how these formulas or this condition works. Let's go back to our work and show you a typical example of how you can use that in nersapp. So assuming in this case here we're trying to get a previous term result in this formula after having our total score here, which is 100, then previous term result is 100 here. So we want to have another column. Say for instance, this should be our final score for that student in this term. And in the final score, you want to add the student first term result, in this case here, this first term here, plus this current term, which would be depicted with the total colon here, which is the test plus exam, and divided by 2. So you want to do something like this: total plus first term divided by 2. That will give you the person final average score for this term. This example is pretty straightforward because you are already sure about the total score here, and also you may be sure that yes, there will be a first term score. So yes, this formula is correct. But if you look closely, you will discover that this first term score can be wrong or may not be correct for some students. For instance, the students that were in first term would not have any problem if you use this formula this way. Why? Because they already have a first term grade or score. How about you have some new students in second term? So you can see that they may not have a first term score. So if you use this formula the way it is, your portal may not compute that work. Why? Because the new students do not have first term score. Right? In most cases, what nersapp does is that if no student or if the student do not have first term score, nersapp would use 0. So imagine somebody having 80 here, the second term, and first term was 0. So you have 80 plus 0, which is 80 divided by 2. So that person will be having a very bad performance. That means the person will have a score value, a total final score value of 40, which is wrong in the right sense of thought, because the person came in second term. So the system should not be dividing by 2. Instead, it should be dividing by 1 because the person came in this second term. So how do we remedy that? So this is how we can do that. So we're going to come here. Instead of using 2 there, just like that, we'll remove 2, open bracket and close, go inside. We're going to use this formula and say things like, if first term is greater than 0, that means that what we're trying to mean here is that if a student have a first term score, whether it's 1 or 100 or 80, as long as there is a first term score, we should use 2 as a divisor. Otherwise, we should use 1. By creating this level of complexity, your formula is correct. So if a student actually have an exam score for first term, the system should divide this total score by 2. If the student doesn't have an exam score for first term, the system should divide it by 1. This way, a new student that came in second term would ensure to have a good final score. I hope you understand this. So that is it. So we're going to save and we're done.